So, organic chemistry, what is it? Well, it's chemistry dealing with chains of carbon. So, if we were to we'll do an example, we'll just do a one chain carbon to make it simple. So, one chain carbon. We'll take C. It has 4 valence electrons. Excuse me, as always. And we not assume, but the best bond to bond with carbon is a hydrogen. So we'll take a hydrogen. We'll take a hydrogen and put it there. And so we'll do that for all the way around, because carbon needs to have its 8 valence electrons to complete it, and hydrogen don't, because they're only in hydrogen and helium are only in the 1s orbital, and they don't need as much. So when we can write this, there's a trick to writing this in a simpler way. We can do a dash around the carbon, and then we can put the hydrogens, and we can say the dashes are necessarily two valence electrons bonding together. So when we do another example, so for this example, I'm going to do a 3 chain carbon. What that's going to look like is C3H8. And so we can write that as we can write that with C having its 4 valence electrons. Then we'll go into another one, and it has its 4 valence electrons. Excuse me. And then we'll do another one. So now you get the basics that we have 3 carbons there. So now when we want to do our hydrogens, put its valence electrons on the outside, and then we put the hydrogens on. And so now we have it all connecting. So now we have 3 C's, 3 carbons, and 3 hydrogens. If we wanted to even write this in a much simpler way, we can even do what we did before with the 1 chain carbon, is put the dashes around each C, and then just now put the hydrogens in. So now there's even much simpler way. Well, there's more simpler ways of even doing this, and you further going on, you'll probably see it is we can take this portion, which is CH3, then this portion of it, which is CH2, and then we can do this portion over here, which is CH3. And so further on you might see it being just written as CH3 dash CH2 dash CH3. Also, it can be written as just CH3 CH2 CH3. A much simpler way than writing all these hydrogens around and putting in the valence electrons and doing all that. But you think it stops here. There's even a simpler way of doing this, which I highly doubt, well, not highly doubt, but you'll probably see it more often than usual, and that is just having it like that. And you're thinking to yourself, how can that equal C3H8? Well, here's the example. We take each endpoint and think there's a C there, and then it having its hydrogens all around it. And so we assume that bonds with 2, those bond with 3 over here, and then we do the same for the side we did over here, is have 3 hydrogens. And so that's pretty much saying what we did over here. And so when we go back, we can write this in the simplest form, or its simplest form possible. So that would just be that, and then we put CH3. It bonds with 2 hydrogens, so we put it over there, just how we see. And then we put another CH3 over here. By the way, this part right here is called an line angle diagram. And you'll see them a lot in organic chemistry when you use it going further on.
Made with Doodlecast Pro.